Okay, and welcome to this video where we're going to look at the SACE Specialist Mathematics Exam from 2019, and in this video we're going to look at question 4. Okay, so question 4 is a question on considering a function and looking at the behaviour of that function, particularly asymptotic behaviour. So the function we're looking at here is f of x equals 1 over x multiplied by x minus 2. Okay, so part 1 is what we want to do is, on a given set of axes, we want to sketch the graph of the function y equals f of x. And we want to clearly show the behavior of the function in the asymptotes. Okay, so the first thing we'd want to do when graphing this sort of function, or sketching it, is look at the behavior of the function, the asymptotic behavior. And the asymptotics are going to depend on what happens when x gets very large and very small, and also when things like the denominator get equal to 0, because if the denominator goes to 0, that means the function f of x itself is going to either positive or negative infinity, given that the numerator is fixed at 1. So what we're interested in is when the denominator equals 0, and we can see just by looking at the function, it's a polynomial, it's quadratic, and it's already been factorized, so the values when that goes to 0 is going to be x equals 0 and x equals 2. Okay, so that divides the x-axis up into 3 regions. There's the region below x equals 0, there's the region between x equals 0 and x equals 2, and then there's the region beyond x equals 2. So when x is less than 0, then f of x is always positive, because we get x is a negative number, x minus 2 is also a negative number, and you're multiplying two negatives on the denominator, so that gives you a positive, and the numerator is always a positive. So as x goes to 0 in this range, so it's going up to 0, the denominator is going to 0, so f of x is going to infinity, and it's in fact going to positive infinity. It goes to positive infinity because the denominator is always positive on that side of the point x equals 2. And as x goes to negative infinity, then f of x is going to go to 0. Okay, and again, it's always going to 0 from above because it's always positive. And you can see that's the case because as x goes to negative infinity, then the two factors on the denominator are both going to negative infinity, so it's going to go to positive infinity. Okay, so now we want to consider the region where 0 is less than x is less than 2. Okay, that's between the two asymptotes. And in that case, we see that x is positive and x minus 2 is negative, and so f of x is always negative. And as x goes to 0, you got f of x going to infinity. And in this case, it's negative infinity because the denominator is negative. And as x goes to 2, f of x also goes to negative infinity. So it goes to negative infinity in both cases. And the last region we want to think about is when x is greater than 2. And in this case, x minus 2 stays positive. When x is also positive, sorry, it's not 0, it should be 2. Let me just correct that. We're interested in x greater than 2. F of x is positive, and as x goes to 2, then f of x is going to infinity, and as x goes to infinity, f of x goes to 0. Okay, because the denominator is going to infinity times infinity, which is just going to infinity. Okay, so that's all the critical things. So we're ready to sketch this graph now. And so what I would do is I would put a dashed line here on the asymptote at x equals 2. Okay, and when we do the region when x is less than 0, it's always positive. It's asymptotic with 0 down here as x goes to infinity. It's y goes to infinity as x goes to 0. The second region, it's negative, and it's asymptotic at x equals 0 and x equals 2. So it looks something like this. It's fairly easy to verify when x equals 1 that the function is equal to minus 1. And so that's why the vertex of that that plot there is finishing at minus 1, at 1, minus 1. And then when x is greater than 2, we get something that looks a little bit like its behavior below x equals 0. And so this is the function y equals f of x. Okay, so that's question for part A1. We've plotted we'll sketch the function. Part 2, on the axis in figure 4, so this is the next figure, sketch the graph of y equals the absolute value of f of x. Clearly show the behavior near the asymptotes. Okay, so this is as before. Except y is greater than or equal to 0. In fact, it's always greater than 0. Okay, because taking the absolute value means that all the times when y equals f of x is negative, y equals the absolute value of f of x is going to be positive. And when it's positive, it's still positive. So it looks the same as before. And so if we do the same asymptote as before, when x is less than 0, we get a plot that looks like this as before. It's always positive, so nothing's changed. When x is greater than 2, we get a plot that looks like that. Again, nothing's changed because it's always positive. But between 0 and 2, we had something that was always negative, and now that's going to be positive as well. So we get a plot that looks like that. And this is the plot of y equals the absolute value of f of x. Okay, so that's the second sketch. That's for question 4, part A, part 2. Now for question 4, part B, we're also going to plot a graph, but the plot we're going to do now is y equals f of the absolute value of x. So this is as before as well, except argument is always positive. Okay, and what happens when x is negative is just the mirror image of what happens when x is positive. Okay, so if we go to the plot and we just consider when x is positive, nothing's changed from the first plot. Okay, so the very first plot, remember, looked like this, between x equals 0 and x equals 2, and it looked like this for x greater than 2. And we're going to do f of the absolute value of x, and so when x is minus 1, it behaves the same as when x is equal to 1. And so we just get a mirror image of what's on the right-hand side of the plane here. And so we're going to have an asymptote at x equals minus 2. And we're going to have another region here between 0 and minus 2. And then we're going to have these asymptotes here. And this is the graph of y equals f of the absolute value of x. Okay? And this is an even function. You can see whatever happens on the right-hand side, the same thing happens on the left-hand side. So that's the plot that we need to do there. And that was basically the end of question 4. So hopefully you enjoyed this video, you found it useful. If you like it, don't forget to click like below. If you want us to look at the other videos as they come up, you can get notified by subscribing to the channel. So if you're interested in that, then subscribe to the channel. And if you've got any comments or questions, just post them below, and hopefully I can get to them soon. All right, thanks very much.